Hey guys, today we have 872 leaf similar trees. It says here consider all the leaves of a binary tree from left to right order, and the values of those leaves form a leaf value sequence. And from here we are to return if these two binary trees are leaf similar. Binary tree meaning they have at most two children, and leaf similar meaning from left to right, although I guess I could go right to left technically. If the order of the leaves, leaf meaning there's no left nor any right children, there's no children whatsoever. This is the lowest children with no other children. If that order is the same between two trees, then we can say that these two trees are leaf similar. So, given that we know the idea, let's run through the helper. The helper function will take in some node and we'll do some things with it, and then ultimately we'll return whether or not the string representation or the order representation of the leaves of the first node is first root is matching the order representation of the second root. And for each of these, all we're doing is saying if the current node is not existing, if this is none, then just return an empty array. And then if not node dot left and not node dot right, meaning this current node that we're on has no children of its own, then that's great. It is a leaf and we can return node dot val. Now otherwise it means it has either a left child or a right child or both. In this case we can return the DFS of the left child plus and these are going to return, this is going to return an array, this is going to return an array, plus DFS of node dot right. And ultimately, this will end up giving us an array of 6, 7, 4, 9, 8. And this will return an array of 6, 7, 4, 9, 8, where the individual values are shared between the two and in the same order. So when we submit, we are able to pass. Now, that is the solution. If you want to understand what this does individually, then I have brought in an example here. So remember that we're going to do a deep dive into the individual calling of, let's say, root 1. Okay, and then so that will ultimately keep traversing, going down until we hit a point where there's nothing. So here would all be empties. Now if we ever reach a point where there's no children, then it will return, so this would return something like, 6. This would return a 7, this would return a 4, a 9, and 8. Anything beyond that, it's a none, so we would not return anything. Now, that's the instance here. If not node left and not node right, then it'll return the array of the value just itself. Now, what about if it has a left and right child, or if it has just one child? Then it will call recursively into the children, where let's say, that this had a left child of 4. Okay, and then this had nothing. Then we would be returning 4. This would be empty, and so instead of a 9, this would be a 4. I don't know if that's clear or not clear, but So as long as there's no children, we return the array of it. If there is either or both child, then we return whatever is the result of recursing into it. And let's say that one of them is empty. That's okay. It'll anyways return an empty array as per this code. Thanks so much. Happy coding. See you next time.